Thank you for joining us for Zero Trust Security with IoT session. I am Syed Rehan. I'm a senior IoT developer evangelist within AWS IoT service team. You have my QR code on the right-hand side here. You can connect to me using LinkedIn or Twitter, ask me any questions related with AWS or AWS IoT or Zero Trust or in general. So let's begin. So in this session today, we will look at Zero Trust and its protection principles. We will also look at NIST and NCSC Zero Trust design principles. These are the cybersecurity organization in UK and US. We will also look at AWS IoT security best practices. These are the ones which I basically advocate to my customers or AWS in general advocate to customers as part of the security best practices to adhere to. Then we will look at a demo and I'll walk you through using AWS IoT Greengrass and AWS IoT Device Client. These are the two open source AWS IoT projects which you can basically use to emulate a real hardware or real device, a real IoT thing. AWS IoT Greengrass is actually edge a runtime environment where basically you can run Lambda components to compute at edge. Within this demo, we will basically look at how to secure these devices using AWS IoT policies and how does it actually adhere to AWS IoT adhere to Zero Trust. Then we'll have I'll take questions if there are any. So what is Zero Trust? So from a NIST, which is a cybersecurity organization in the US, they always say that the cybersecurity paradigm, you need to make sure the network-based parameters to focus on users, assets, and resources, right? And you need to make sure that there is no implicit trust granted to assets or user based on their physical network location or the asset ownership. For example, somebody who's basically a root user or admin user, and you give them complete network access and allowing them to access your backend, it is against Zero Trust guidelines and principles, whether they're based over VPN or they're basically doing it over physical based on the office location and whatnot. Similarly, NCSC, which is a cybersecurity organization, a government agency in UK, they say that there shouldn't be a direct trust, and inherent trust in the network is removed. It should be removed. Always assume network is hostile and each request is verified. So for example, network is assumed hostile. You may never know who's actually snooping and eavesdropping, and always each request is verified, basically backing that up with the policy and backing them up with the authentication and authorization to make sure it's a right user, right level of privileges has been applied when the user is accessing the environment. So protection principles for Zero Trust. So these are some of the protection principles. When I have a discussion with my customers, I always look at and I basically tell them that to look out for within your own protection guidelines or security guidelines. Make sure you're always paranoid in a sense that internal and external threats always exist, right? Never assume that whether the internal user or external user, they are verified and they are valid users, so there won't be any compromise on situation, right? Assume hostility. Always assume each device is hostile. So if we take the Zero Trust principles and hand, we will look at to see that every device is hostile, right? And this goes hand in hand with the rest of the other principles which we're going to talk about, to make sure that if the device, whether is actually owned by IT director or IT administrator or a developer or whatnot, you need to make sure that every device is hostile, because we never know what device could be used as a bed or a conduit for an attacker to basically gain access to your environment. Gatekeeper, this is one of the rounding ones where we basically look at authorization and authentication, every user, every request, to make sure that you have a gatekeeper in place. Most organizations do have gatekeeper in place, but usually some of them actually has a caching mechanism where they say, okay, we have authorized and authenticated this user or device, and we will have this available and valid for the next 5 days and whatnot. You shouldn't do that. You should always make sure that you authenticate and authorize every single time to make sure that your gatekeeper is always up to date. Trust issues, I think we talked about earlier from the NIST principles, as well as NCSC, that trusted device are never trusted. So, for example, as I mentioned earlier, if somebody is in management, or somebody is basically a developer, anybody in company is basically trying to connect to the environment, and they have a trusted device and they have root access, they shouldn't basically get automatically inherently gain back access to the environment, because these are against zero trust principle, because this can lead to causing of your backend to compromise. And then we can also look at guard, update and change policies dynamically. For example, if your device has been compromised, you need to make sure that you're updating the policy dynamically. If a user laptop has been stolen, you're updating the policy dynamically. If the device, IoT device, Internet of Things device basically has been compromised, you're updating the policy dynamically. Taking what I've just mentioned, let's take it and apply security best practices when basically talking about Internet of Things, or an asset basically trying to connect to your environment, whether it's a cloud or endpoint. Always decouple ingestion from processing. For example, we have two types of control plane. We have a data plane and we have control plane. Data plane is where the device is actually sending you sensory data, telemetry data. And then we look at control plane, where you control the authentication, authorization, and whatnot. The category of the device to basically allow it to basically connect to the cloud or endpoint is where we should decouple this from processing. For example, let's say if a device becomes compromised, and you know that you have a control plane separately, you can basically lock the device out. And we will look at the rest of the best practices below. You can basically always make sure the device is actually out from the environment, but is actually functioning as an offline behavior. Gives a segue into the next point, which I was going to talk about: design for offline behavior. Make sure your device is actually capable to run offline. Let's say, as I mentioned earlier, if the device being compromised and you want to basically apply the control plane and lock it out from the environment, from the cloud or your endpoint, your network, and make sure it works offline behavior. For example, I actually have a humidifier. It's connected to the internet. I can control it using my mobile app. I want to make sure that if the basically device becomes compromised, I would basically still have the normal regular functionality available from the device, and it shouldn't be compromised. That I shouldn't actually have a device which is basically not performing what is basically designed and tasked to do. Design lean data at edge enriched in the cloud. So, for example, any IoT device, or in fact any asset, whether it's connected to the cloud or connected to on-prem environment or endpoint or whatnot, always will generate tons amount of data, right? We could go to zettabyte, petabytes, and whatnot, right? And we need to make sure that we remove the right data or rich data with the noisy data. So, for example, if you have a device connecting to the cloud, you need to make sure that you are taking the lean data and applying it into the cloud and basically using it to do BI on it. You don't want to basically have a noisy data as well as rich data coming to the cloud and then you enrich it on the cloud. No, you should basically apply the design principles to say you have a lean data at the edge. So you basically could use something like AWS IoT Greengrass, which basically works on the edge and offline to give you enriched data. So it basically you can run compute at the edge using AWS IoT Greengrass. An example of that. So you could basically have a lean data coming to the cloud, which you can enrich by applying, normalization. You could apply Kinesis Firehose or any other sort of a data lake, putting into data lake and enrich it for your BI users, analytics, and whatnot. Personalization. For example, you need to basically handle each device differently. You can't basically have one go solution for all. For example, you may have a connected car. You may actually have a connected fridge. You may have a connected microwave. They all have a different functionality. You need to basically handle personalization, tie them up with the offline behavior, tie them up with the decoupling injection from processing. For example, a car is basically a totally different machine compared to a microwave or fridge. Main task is basically making sure keeping things cold and not to make sure they go rot. Similarly with the microwave and similarly with the car. So for example, you wouldn't want to basically compromise a car and you would basically lock that car down to make sure it is not working at all. I mean, car when it's actually moving, it will create telemetry data in terms of where it is actually going, the motor, the battery, the brake pads, the fluids, the pressure, so many things, the moving parts within the car, will basically give you a telemetry data, which obviously you can enrich at edge, normalize it, and then send it to the cloud for you to utilize that. And also, you can apply personalization for it. For example, you can't apply an EV car, which is electronic car, battery running out, and you basically notifying the user and routing them up to the local closest EV charger. You can't do that, obviously. With a microwave, it's totally different story. So you need to basically handle personalization also to make sure that they allowing the devices to basically work offline. So there is no compromise of feature and usage of the device, what is designed to do. And also ensure devices regularly send status check. For example, some customers basically send status checks like every 24 hours. Well, that's fine. You can send over 24 hours, but then that depends if the asset is actually moving asset, is portable asset, what's the priority of the asset and whatnot. Some customers actually send it every 5 minutes. Some customers send it every 1 hour. It all depends on how you want to basically make sure the device is actually sending the status check and regularly sending the status check. Also look at device security lifecycle holistically. So the device security lifecycle holistically ties in very well with the one of the other principle, which is identify lifecycle management. So for example, you actually have a device and it is a greenfield device. You want to basically make sure it's gone into the field. You're having a proactive action on the device, whether the certificate becomes compromised or somebody's trying to clone the certificate of the device, or if the device basically has become too chatty and whatnot, you basically compromise the device connectivity to the cloud by saying that, okay, I'm going to apply privileges and the policy by locking it down, and then implementing device identity lifecycle management. So for example, if a device becomes chatty, you want to basically put the device into a quarantine group or quarantine zone where basically you can apply restricted access to the device in terms of it can just send you the data and cannot receive the data from other devices or from the cloud and whatnot. And it is also, it is functioning, but it is not basically functioning to the 100%. You have not basically made the device redundant. It is capable of carrying out the function is designed to do. But you want to basically make sure that in terms of the device security is you could basically use, for example, in this case, AWS IoT secure tunneling feature to log into your device using SSH tunnel over MQTT. And the device basically will say, okay, you're connected to me. You can basically restore its firmware. You could basically restore its state to the previous working state, or look at what actually caused this anomaly, right? So it goes tied very well together and hand in hand. Least privileges, again, start with least privileges and grant them elevated privileges as and when needed. You shouldn't give them, if you're talking about from AWS policies perspective, if applying a star for everything, it's just not the right way to do. You need to basically make sure and understand what the device is actually connecting, is sending, what is publishing, what is receiving, and whatnot. So apply the bare minimum policies and permissions for the device to basically connect to and be functioning for your environment. Secure device credentials as rest. So, for example, you may have a device which basically have a TPM, which is the hardware module for you to encrypt the device credentials or certificates when it's trying to connect to the cloud. You could, if you don't have a hardware TPM, you could also set up a software-based TPM within your environment or within your devices and whatnot, and this will basically encrypt the security credentials and always making sure that it doesn't get compromised at rest. I've already touched that about implement device identity lifecycle management. It goes hand in hand with device security, where I mentioned that you need to look at the complete holistic view of the identity of lifecycle management. Also tying with the previous practice I've talked about is that each category should be personalized differently, whether it's a car, whether it's a fridge, whether it's a microwave, kitchen appliances, external lights, or whatnot. They all should be maintained and managed differently based on their identity lifecycle management. And machine learning. So as human, our level of reaction and response can never be equivalent to the computer. So if you actually have, let's say, machine learning, right, and you actually have a compromise situation within your environment or your devices get compromised, if it's a machine learning, it can immediately uh, notify you and apply the lock and basically quarantine the device, so it doesn't basically violate and create security risk for you for other devices and within your environment. So this is where I always say to my customers, use machine learning where you can. Always apply machine learning where you can, unless the devices are not capable to. I mean, there are two types of machine learning when we're talking about here. One is at actually cloud side machine learning, where you have the capability to train the model and apply cloud side machine learning knowledge. And then we also have something called machine learning inference, which basically you can apply machine learning model, train it in the cloud, and apply the inference of it at the edge devices. These devices could be an MCU or a small Raspberry Pi. They are capable of running machine learning inference because you're not training the model, you're applying the inference at edge. Finally, take a holistic view of data security. You need to make sure if the device basically is connected to the cloud, it is basically, or in fact, connected to your environment or on-prem, wherever endpoint, you need to make sure the data, it never gets compromised, because you don't want to basically lose the faith and trust of the user if the data basically gets compromised. So have a holistic view of data security and making sure it ties in with the device credentials by using TPM, the hardware module. So make sure the device never actually comes to a state where it can become compromised for a snooper or hacker who's trying to basically obtain the identity of the device and obtain access into your environment. Let's look at telemetry before machine learning. So I mentioned earlier, apply machine learning. So if a customer basically is unable to apply machine learning due to the capability of the device, or the device at edge is not capable to handle machine learning, then you can basically use something called AWS IoT Device Defender. It gives you the capability in terms of security profile to apply the data set, apply the algorithm to say that if the device becomes chatty, or if the credentials has been compromised and whatnot, notify the user through Amazon SNS and log it into CloudWatch, and then also send a trigger using Lambda back into the device to say that you need to basically stop sending this data. Also, from when it's connected to the cloud part, you can basically use Lambda to move the device into a quarantine zone. But obviously, these are the manual steps where you will need to do as part of your setup if the machine learning cannot be applied. Now, let's look at defending devices with Amazon machine learning, right? So if you have a device which is capable of sending you data to the cloud, or an asset which is sending you data to the cloud, you could basically use the data, put it through Amazon SageMaker by cleaning up the data into AWS IoT Analytics, having the channel, the pipeline, data store, and creating a data set. Now, this data set will be used by Amazon SageMaker to create the model. You can basically take the model and apply into Amazon S3, and then this model can be sent back to the device at edge to say that, okay, we have created this ML inference, and for you to basically apply this locally. So this could be a microcontroller, it could be a Raspberry Pi, or it could be a full-blown industrial edge environment running a normal operating system. These can be sent back downwards to the device to basically handle this. You can see here, we also talked about AWS IoT Device Defender, which will give you the capability to look at, certificate the policies, audit it in terms of whether the device is basically been compromised or not. Make sure you grant permissions based on what the user basically need on need-to-know basis. Finally, let's look at automate and eliminate risk by applying inherent and inbuilt feature of AWS IoT Device Defender ML Detect. Now, in this feature, you will see that AWS IoT Device Defender ML Detect contains policies, permissions, audit, and takes the holistic view and take all of that into a machine learning model. It takes a machine learning model, creates the model for you, and takes proactive action. It gets to work for you. So, for example, if there's been a compromise, the machine learning model will notify the user using Amazon Connect or Alexa devices, and notify the user using a mobile app which you have through AppSync and whatnot, and take mitigation action for you to notify that, okay, the device has been compromised, there has been a violation. You basically have taken the action and move the device out from normal zone into quarantine zone until you can basically rectify the situation. With that, I'm going to move into a demo. So this is a demo architecture which I'm going to show you what we're going to look at. So I'm going to use AWS IoT Greengrass and AWS IoT Device Client to show AWS IoT Think or IoT Think. You can basically use these open source services, open source software, I should say, to emulate IoT thing. We will look at the device policies and permissions by applying least privileges, and then basically taking this and looking at the visibility of the violation of this device is actually creating. For example, looking at device defender, ML detect, or rule detect for you to know that to apply the algorithm to see if there has been any compromise so you can take those actions. Finally, we will look at Security Hub, AWS Security Hub, which is one of the security services we have in AWS, where you can look at complete single pane of glass, where whether it's an IoT device, whether it's an asset or as a computer connecting to the environment, to your whole AWS org, you can basically see the violations showing up in there, whether it's EC2 and whatnot. So giving you a complete holistic view in a single pane of glass. So with that, let's switch over to AWS IoT Core and AWS Console to look into this. From AWS IoT Console, let's look at connecting a device to the environment. You have an option to go through this as a wizard, creating a new thing, give it a thing name. The wizard will guide you through to set up the SDK and platform. If you need, you can set it up for Node.js, Python, Java. Let's just go ahead with Linux and Mac, download the connection kit, and complete it. And we're done with that. Okay, so we also have a test client. So this will basically allow us to look at the data coming into our cloud environment. So you can see here, I'm actually using AWS IoT device client to send some sensory data over here in terms of temperature, pressure, humidity, and date and time. So these devices are backed by our security certificate. So if I go into security, and if you go into certificate, each device basically has a certificate, and the certificate ties in with the policy. So here, if you look at deny all policy, which means that we are blocking the device in here and not basically giving any actions or resources to do in terms of deny action, right? We also have something called AWS IoT Device Defender audit feature, and I usually say to my customers, schedule an audit. So for example, if I go ahead and create an audit here, we basically give you 14 best practices for you to run audit against. You can run it ad hoc, which is just now, or you can run it bi-weekly, weekly, monthly, or daily. So I just do once ad hoc one now. And I'll look at the one which I created earlier, and we can see what are the non-compliant. So if I go into that one, we can see that there are some devices basically sharing a certificate. There's some overly permissive policy. There are role aliases, and so on. So if you basically were to mitigate an action, we will basically go ahead and run this and start a mitigation action. And this overly permissive policy will basically get mitigated. And we can basically run this mitigation action to say, go ahead, do this, and apply the reason for it, and so on. So it will complete the task, and it will block the policy, making sure that this is not overly permissive. Right. So let's go into a security profile, which I mentioned about the machine learning part. So we have two options here when it comes to machine learning. We have rule-based setup for security profile, which means that if I basically go ahead and say it needs to connect to all the things or all the devices which are talking to AWS IoT. So let's say Conf42 profile, and I can select the metrics. So we support cloud-side metrics, device-side metrics, and custom metrics. So for example, if you have devices which you want to understand the CPU usage and whatnot, you can do that as a custom metric. And remember the architecture diagram I showed you earlier, where you had SNS topics, so you can send SNS to the end user. So for now, I'll just leave that for now. And then the significant difference between rule-based and machine learning-based is here. So for example, in authorization failure, you're actually creating an algorithm to say that, notify if this happens absolutely or relatively, and based on greater than, less than, or equal to, let's say, a value of 3 in the last 5 minutes, 10 minutes, 1 hour, whatnot, right? And you have similarly for disconnect, you have it for message size, you have it for rest of the other metrics. So I'm going to cancel this one for now and basically go and show you the difference between this one and the machine learning based one. So let's look at machine learning based one. So if I select it for all the things and give it a name, and let's select all the metrics. And in here, similarly, just like that, you can set up an SNS notification. And let's go into the next section. And in the next section, you can see there's a stark difference here. We basically just take the data points for you to trigger for us to trigger the alarm, and when we should basically clear the alarm. Rest of it is basically taken care of by machine learning. So let's go ahead and complete this one. So if I create this ML profile, it basically allows you to basically have this machine learning model created. So if I go in here and look at the behavior ML training, so you can see that it's pending build. It's not being created. So it needs 25,000 data points for it to basically get triggered and active in. So I usually say to my customers that while this model is getting built, create a rule-based profile for timing until you basically this kicks in. So the moment you basically have 25,000 data points, it will trigger the action and it will basically go ahead and start taking actions for you, notifying it for you. Okay. So the other thing I also wanted to show you is effectively if the device basically becomes chatty. So we can basically look at alarms. So we can see let's say if I basically look at a historic alarm and see the alarm behaviors actually has happened in the last 24 hours. So I have been very good. I've tried to make sure my devices don't compromise in any shape or form. So if I basically look at a previous alarm, if once it basically loads up, so we can see here DDML6 is a previous alarm. Let's tie into the profile policy here. So if I go in here and look at it and see why it basically got triggered an alarm, right? So let's go into the IoT thing itself and look at the certificate basically is attached to it. And within the certificate, let's look at the policies basically using, which is causing the problem. So let's look at this policy. So we can see here that there is a complete violation of this policy of zero trust. And we need to basically make sure that this device basically shouldn't be allowed all action on IoT resource, right? You need to basically lock this down. So we can basically run a mitigation action on this device by creating a mitigation action. Let's say action. And it basically, you have multiple options here. So I'll say add things to the thing group, and I'll basically use IoT IAM role which I created earlier, allowing me to basically carry out this action. And we can basically use DDML group. This is where the device basically existed. And if we run this, and we can basically block the devices. So let's come over to thing group. So basically, I have something called quarantine group, which is where I basically make sure all my devices which are compromised goes into a quarantine group, and it has a policy attached to it to make sure that it has a deny all. So that means the device is actually isolated, can't do anything. So now let's look at the final part of the diagram for the demo, where I mentioned having a single pane of glass. So here we are looking at AWS Security Hub. So if I go into Security Hub, you have options to create integrations to many, many different services. So in here, if I basically click on integrations, you have chatbot, guard DOT, firewall, detective, health. So also AWS IoT Device Defender, audit, detect, Macy, and whatnot, right? So I have some of them enabled, and you can see here it will show up as if the button shows up as stop accept finding, that means that it's basically accepted finding, just like it says over here as a status, right? So if I basically go into findings, this is where we'll get a single pane of glass of everything which is happening within the AWS account, whether it's EC2, whether it's S3, whether it's IoT. So we can see here, we have an EC2 environment, a security group. We also have IoT devices, which are basically writing to security bucket and whatnot. So you can basically look at all of these in a single pane of glass to have a single security view for you to notify if there's any situations been happening and to basically take actions on that. So with that, let's switch over back to our presentation. And within the presentation, we can see here, we just completed that, the demo. Now, I wanted to share some of the links with you. On the right-hand side, you will see a YouTube channel. So as part of AWS IoT developer advocate team within AWS IoT service team, we have our AWS channel where we basically occasionally and routinely publish videos. So it will be good for you to subscribe. And we also have Dev2 space for you to basically look at any microblogging which we do. On the left hand side, the right hand side is a QR, and the left hand side is a workshop links and some other links. So there are 3 distinctive workshops which I wanted to mention. First one is Get Started with the AWS IoT.com, is where you can basically get started and learn about how to basically connect devices to the cloud, how you basically can leverage and set up IoT if you want to learn IoT. Then we have security focused workshop, AWS IoT Zero Trust Workshop.com. It is completely designed from ground up to be focused on zero trust. And then finally, we have Greengrass Workshop, which I mentioned earlier, our feature, our open source software, Greengrass, which runs on Edge. And you can also look at the source code for these open source projects which we have, which is AWS IoT Device Client and AWS IoT Greengrass. Both of these are used within this workshop. Finally, thank you very much from me for listening to me. And as I mentioned earlier, if you want to connect with me on LinkedIn, these are my QR code for Twitter as well. I'm always happy to help to anyone who's basically looking to seek information or have any blockers where I can unblock them. Thank you very much. Have a great day.